Welcome everyone. Today we're going to talk about isometrics. This is our final lecture of the semester. It's a little different than what we've done in the past, and I'm going to tell you a little differences between the axonometric oblique plan, which we did prior, and isometrics. So let's get started, shall we? So we want to talk a little bit about first, we're going to look about isometrics. And like I said last week, so we're finally at the finish line. Now, just a little review. In the past, we did multi-view drawings. As you guys know, you've worked very hard on those. And multi-view drawings are those two-dimensional drawings, the top view, the sides, the elevations, the sections, and the reflective ceiling plan. But remember what we said, this does not tell the full story. And so we're going to adventure into something that gives us an idea that's a little bit more three-dimensional. So we also talked about our paraline drawings, which you guys did one with a large house. But this time we're going to work and do something a little different. But paraline drawings, general conditions for paraline drawings, just to update you, is they have a three-dimensional characteristic. But what they do add also, as we discussed in the past, is an extra axis, this vertical z-axis. We have a y, an x, and a z. Always in a paraline drawing, you'll have a corner that you start. So basically it's tilting an object to have a corner, and we create a three-dimensional look. Here's a corner, here's a corner, and here's a corner. As you see, these are a little bit different. Now, the top one is what we are going to look at, is more of an isometric. In the past, we did a plan oblique, and we learned about an elevation oblique. That's actually taking the drawing and using it. Here it's a little different with our isometric. But basically, they all have three characteristics that are the same. They all have a width, a height, and a depth. So we have to see how wide, how deep, and how high things are. We call it a paraline because this drawing is parallel to the other lines. Now, they also represent very much of a three-dimensional view. And they have axle lines. They're on the axis, so they're tilted. And they're usually in an orientation that's rectangular. Like I said, it gives us the viewpoints of different parts of the shape when we tilt it. They have nice non-scalable features, and also they also have mapped paraline and non-axle lines. So in a plan and an elevation, you only are dealing with your X and Y axes. But in our paraline drawings, we add that Z. So you see, we're taking something, tilting it, and then creating a three-dimensional object. In a plan view, you only see one side of it. But once you tilt it, you see several sides of it. And that's our goal, to create something that looks more realistic and more three-dimensional. So in our pictorial systems, we have different models that have different effects. Once again, these are the three general characteristics. And this is just basically a review. We have we use orthographic projection, remember, for our plan and multi-view drawings. We also have our axonometric projection and our oblique projections. So we use orthographic projections to help us with some of these drawings. Now in perspective, it's a little different because this is the most realistic three-dimensional form. There's 1-point perspective, 2-point perspective, and 3-point perspective. However, we're not going to discuss that. You will have a course that will go into that in further detail. But what we want to discuss is more this axonometric viewpoints. So the isometric are this top one here. And they show three different sides. There's different kinds of different axonometric drawings, but the one we want to talk about is isometric, which means one. There's also diametric and trimetric. That's 3 different sides. But this one deals with iso, meaning one. And what it means is that there's only one angle used in the entire drawing, and it makes it completely even on each side. When you use a dio, you use 2 different angles, which doesn't make the viewpoint equal. And when you use a tri, you use 3 different angles that create a different viewpoint altogether. But isometric, we're going to dive right into. So isometric drawings, understanding them. Well, basically, how are they different? Well, they establish a lower angle of view than a plant oblique and give equal emphasis to, once again, all 3 principal sets of planes, or just another fancy word with all 3 sides. Angle of the view is slightly lower than a plant oblique, meaning when you see an isometric, it's like tilted more. So you're not looking at it really full at a different angle right at you. It's kind of tilted and it looks more realistic that way. We did the Plant Oblique, which was using a floor plan, tilting it, and it was coming straight at us. The isometric is going to be a little more tilted, a more realistic viewpoint. So you don't quite see as much inside as you do with the other Plant Oblique. Preserves the relative proportions of the subject or scene and are not subject to the distortion inherent in the oblique views. So they look more realistic. Plans and elevations cannot be used as a base for these drawings. And you must use a scale on the plan drawing as a reference only. So those are the 2 main differences. In the plan and elevation oblique, we're actually able to use one of those multi-view drawings as a reference, and it makes it super easy. You just put that plan view on, and you start raising up all those vertical lines and connecting them. With the elevation oblique, similar. Use an elevation, you start projecting those lines right off the drawing. Well, in an isometric, you actually have to put your scale on the drawing, the reference drawing, bring it to your paper, and using your triangle, scale out each dimension physically. So that's why we can't use the plans. So an isometric versus a plant oblique, like what you did. You see this isometric, it's more tilted slightly, where the plant oblique is extremely, an extremely exaggerated version. You could see inside more. Remember when we did our plant oblique, we used an actual floor plan and then just raised up all of the walls right off the floor plan. Here in isometric, you can't do that. It's tilted back more to give us a more realistic viewpoint. The paraline drawings are this 3-dimensional illusion of forms. Like I said, the paraline drawings, they have different types. The axonometric view, like we discussed. The isometric view has 3 axes and they're equal angles. Right here, they're exactly equal. And so you're seeing the equal amount of each picture plane. That diametric, di meaning 2, you're seeing 2 of the 3 axis lines with equal angles. So this is a different angle, and this is a far more exaggerated angle. And then this is the same angle. So that's why you have an angle here and an angle here, and that's 2 different extremes. And then with the trimetric views, you have 3 axes with 3 different angles on the picture plane. You have this one, and then you'll also have this one exaggerated a little differently, so creating a different viewpoint. But today, we're going to talk about the more common isometric. This is the one that we use most readily and common in our drawings, especially in AutoCAD. So, as I said, this paraline drawing, this isometric and oblique drawings too, but the isometric drawing, equal emphasis on each plane. So you see here, there's a 30-degree angle and a 30-degree angle. From one angle to the other, it's exactly 120 degrees. Same here. So here we go, and it's a 30-degree and a 30-degree. You view the lower, the angle lower than an oblique, like I said. Plan and elevations not directly used in these at all. You are actually going to be using your 30-60 triangle. So when you put a horizontal line, you put your triangle right on that horizontal line, and you will draw a line that goes off one direction and a line that goes off the other at a 30-degree angle. And then, of course, your vertical line, which is your z-axis. This is how we start all of our various isometric drawings. Paraline types. So the isometric and these oblique, you have to be careful because they do give an optical illusion that causes difficulties when interpreting it. So when we do our isometric, we start off, these are all at 30 degrees here, and you start to measure, you bring up more, and they continue at that same angle, 30 degrees this way, 30 degrees this way. This creates a carved out space. And this is what we'll be doing with our kitchen. It's basically just similar. It's just a bunch of rectangles or squares that create our cabinetry, our upper cabinetry. And it's like we get to see a peek into the space. And this does give us this three-dimensional viewpoint. With some Paraline drawings, we like to use different approaches when constructing our drawing. And you'll see this too when we do our kitchen corner. You like to start off with a rectangle. So in our drawing, we will create the length of one side of the kitchen, the length of the other, just kind of connect the lines, creating a rectangle. And we will start at the corner back of the room. Here we measure out a certain amount of feet, 3 feet for cabinetry, and bring that out, lift it up 3 feet and back. Basically what you're doing is carving various shapes within your rectangle box. And that's how we'll be working. It's just a process of carving various shapes, measuring them out, and pretty soon you will see that you have a three-dimensional shape of the object. So you start carving out the elements and kneading, and then removing those that are not important. So you start erasing elements, and it's just like chiseling away at a piece of stone to reveal the form. In this case, here's a room. Something like what we're going to be doing is we'll be doing a corner of a kitchen. So first we've created, the actual plan, the floor plan at the bottom. How do you create the isometric? Well, you measure from the floor plan as your reference drawing and you scale it. So you go to your regular floor plan and you see, okay, that floor plan is 20 feet. So you take your 30-degree triangle, you create a line this way, and straight up, and you measure that 30 feet with your scale. Then you find out what the other dimension is. You go to your floor plan, you measure that, and let's say it's 28 feet. So you measure 28 feet. Now remember, you can always scale up. So if you have a 1/4 inch floor plan, you would go and use your scale and measure it in your 1/4 inch. But let's say you wanted your isometric in 1/2 inch. So 1/4 inch, 12 feet perhaps, go flip over to your 1/2 inch scale and mark down 12 feet on that. As you create your X and your Y lines at a 30-degree angle, where they meet, you just scale out one way and you scale out the other. Where it ends, you create more vertical lines. This will create a rectangle to correct scale. So you're not using your floor plan as the reference. It's a little more work by placing your scale and then converting that scale onto your lines, your 30-degree angle lines. So you would then use your 30-60 triangle to lay out the area that you want to draw. Okay, so first you just kind of create that rectangle. And then once again, you're using the dimensions from the floor plan and draw on this picture plane that looks like a flattened rectangle. It's kind of tilted back. You use elevations to scale the ceiling height. So you would go back to the multi-plane drawing of elevations and see how high the ceiling is from the floor to the ceiling. So you reference your multi-view drawings in order to create the correct scale, three-dimensional isometric. So you use the elevations to find out the ceiling heights and heights of all the cabinetry and so forth, and of architectural features such as windows, doors, and anything else that might be of importance. And so as you scale on your elevation, you scale up high, or let's say you want to find out how high this little cabinet is. You found out on your elevation it's 3 feet. So you put the scale up 3 feet, and now you created another 3-foot bookshelf. So basically you're taking those dimensions off the floor plan and elevations and then recreating them in this multi-plane view of isometric. So you'll scale this way, and heights. And so you see, we're trying to create this little tilted version of almost like a model. And if that were made out of foam core, and the more you tilt it, the more you can see different angles. So as an oblique plan view, you're tilting it more towards you at a 45-degree angle. At an isometric, you're tilting it less towards you, and it's going to be more subtle and flattened. So that's what we're trying to achieve. So as you take your scale and you go on the and then you put it onto your picture plane at that beautiful corner that you've created, you start to carve out each component. And pretty soon you have amazing drawing just like this. Every item in here has been carved out, scaled, and it's to correct scale, and it really looks realistic. You always add too a little extra, for your molding and make everything more three-dimensional. So for every line, for every plane, you're really dealing with 3 different lines. And so hence really making the object look very three-dimensional. Just like anything that I would have, let's say it's this. From the elevation, you can't see it. From the plan view, you can't. But the moment I tilt it, you start to see various components. Same with, let's see, I wish I had a better viewpoint. But this coaster, you couldn't even see from an elevation. Here, a plan view. But the moment I tilt it, you're seeing this side, and the top. Now, if this were the oblique plan, you would see far more of the top. But now, when you do an isometric, it's a little more flattened. So, like you said, when you can't see the plan view, you can only see the elevation, you have no idea what the entire shape is going to be. So, as I said, this is our final lecture for the semester. And I am excited, and we're going to talk a little bit, we're going to see just a little video on some of the basics of isometric.
During this tutorial, we'll look at how to draw the most basic 3D shapes in isometric, a cube. So an isometric shape always has an edge, like a front edge that faces the viewer, and it's from this edge that we'll make our start. So let us assume that our isometric shape is 100 millimeters in height, width, and depth. What we can do is start by drawing that front edge. And so I've got a pencil here, I've got my T-square, and I've got a 30-60 set square, so-called because it has a 30-degree angle here and a 60-degree angle here. And of course this is a 90-degree right angle. So let's begin by drawing our front edge. So we line our set square up on the paper, draw a vertical line, nice and lightly. You can probably just see that there. And I'm going to measure 100 millimeters. So from 0 to 100. And I'm just going to darken this in so you can see it a little bit more clearly on the video. So that's the front edge of our isometric cube. Now, every angle in a basic isometric 3D shape is set at 30 degrees. So all the lines going back from the front edge will be at 30 degrees, so at this angle here. And all the lines going back in this direction will also be at 30 degrees. So I'm going to draw in some lines that go back, that will be the sides of our cube. Nice and lightly. And then on the other side. And I'm going to do the same from this top point. So remember, this is 100 millimeters higher than this bottom point. We're going to draw some 30-degree lines that go backwards. So from that top point, nice and lightly, and then I can measure in 100 millimeters on each edge.
Now as you see, he's using
It's 100 millimeters from there to there.
metric, but we would use a regular scale.
Same there. Same there. And the same there. And if you've done this accurately, then these 2 points that you've marked here and here should line up horizontally, vertically, sorry. And they do, so I'm quite happy about that. Make these nice and dark for you to see. And then these 2 points here, they should line up vertically as well. And they do as well. So I'll mark those in nice and dark. So you can see our shape beginning to take form. I'm going to make these lines here between the front edge and that side edge nice and dark. Do the same for this side. And all that remains for us to do now is to put the top on the cube. So again, because this is an isometric shape and it's a basic shape, we will just use our 30-60 set square to make the spinal line. And so we can do a line here going backwards, and from the other side, a line going backwards. And the point at which they meet is the back of your cube.
So it's just a basic shape, but this is basically the form you use all of.
So there you can see the most basic 3D shape in isometric, a cube. Its lengths are 100, 100, and 100.
Okay, so that, my dear, ends our lesson. And it's not really week 9. It's actually, we are week 15. So I'd like to thank you guys all for sticking it out, and I know you'll do fantastic. So go ahead and watch the demo video of our kitchen, the isometric of doing that kitchen corner. I know you guys will do great, and I will see you then.